I've always liked the shape of the RF-101, so when the Kitty Hawk kit became available, I thought it'd be a simpler route to a more state-of-the-art conversion, with basically just the creation of the recon nose. I also thought that doing the recon nose would make a good video demonstrating a basic scratch building technique. Unfortunately, after starting construction, I found the Kitty Hawk kit to be quite disappointing in engineering as well as execution, and not worth the effort. However, since I'd already fixated on the RF-101, I decided to get some use out of the Kitty Hawk kit as a conversion to the monogram kit, and that's pretty much my final thought about the Kitty Hawk kit. The C cockpit was grafted to the monogram kit. Several different drawings were put together and resized in Corel Draw. I established a datum line through the most forward contour of the nose. Here you can get a pretty good idea of where the new nose section needs to take off. Using the kit perpendiculars, the cut line is measured and marked with tape. Once that looked good, I used a blade to transfer the cut line to the model. After cutting away the majority of the forward section, the edge is refined with a large flat file. A large flat file will provide the most precise abrasive surface, and as a general rule, work up to your line, but don't remove the line. Once you remove your line, you've lost your reference. I decided to shape the nose from basswood. A block needs to be prepared and marked with appropriate center lines. I'll be using my bandsaw to prepare the block. With any bandsaw, there's some inherent slop between the blade guides as well as blade flex. To minimize the error, the blade guide should be dropped down near the surface of the material. A general dimension from the center of the nose is taken off the drawing and transferred to the bandsaw. The issue is that the fence is too tall to allow it to be set that close to the blade, so the workaround is to use a piece of 3/4 inch material against the fence as a spacer. In the end, I cut 4 blocks that when glued together will give me a generous amount of material to work with. The first surfaces to be glued together were given a coat of black paint. 2 pairs of the blocks were then glued together. After the glue's dried, a fresh edge is established by running them through the bandsaw again. Again, the surfaces to be joined are given a coat of black paint. The final block goes back through the bandsaw to even things up. The block's now square with center lines all the way through. After you've finished with any bandsaw, release the tension on the blade so you don't damage the rubber on the wheels. A small bandsaw is an extremely handy addition to any shop. They're relatively inexpensive, extremely versatile, and occupy a very small footprint. The profile drawing is glued to the side of the block. The first cut is along the top. I finished the cut on the disc sander. The second angle cut is the front. The bottom surface of the block will be the last cut, and it serves as an additional reference. Because of the slope, the top profile needs to be stretched about 80 thousandths. With a lot of the gross reduction done, you can pretty much start to see where this is going. The nose incorporates 2 flat tapered sides inclined at about 73 degrees. A digital angle gauge or digital protractor works well for setting the angle of the sander table. Once the angles are cut, I stuck a profile drawing to the upper vertical part of the side so the paper's not bent. The last reduction is basically done by eye using the angle from the drawing. Here's the nose after the final reduction. The underside was over-reduced to accommodate a piece of acrylic. Since there are a number of camera windows close together, I decided to use one solid piece of acrylic with the underside painted black and then mask off the individual windows. Now the fun begins. Using the existing fuselage, front cross-section, and center lines as guides, you can work from photos to see if you can create something that looks reasonably correct. There's no kit manufacturer to blame if the shape's wrong. In reality, for me, this is the most satisfying sort of modeling. Reference lines along with sharp angles help keep things on center and symmetrical. Note how the rearmost portion of the flat side finishes out because of the tapered nose. As the individual elements fall into place, you gain an understanding of how the original shapes were formed. Here's the final shape. I hope this quick and simple project has illustrated the usefulness of establishing reference lines. It's one of the most basic approaches for creating shapes, and I hope it's given you some ideas for creating your own conversions or Scratch-built projects.